Let me also start the recording. All right. So before we start the discussion, do you have any questions for me? So a quick recap of what we are doing right now. So we wanted to discuss about Apache Spark. We had already started the discussion on Apache Spark. It's essentially a faster way of doing the computation. Okay. So Spark does a little bit faster, not little bit actually, around 10 times the usual MapReduce. And it's fairly fast because it utilizes the memory of the computers as much as it's available or is okay to use. All right. So so this is the general architecture. So basic thing is that there is something called a Spark core, which can run either on Yarn cluster or any other similar clusters, whether EC2 or Mesos, or you can set up your own cluster. Also, Spark can connect to many kind of databases. All right. On top of that, the advantage of using Spark is that it comes with various kinds of libraries, such as for streaming as in handling the live stream of data at a very, very fast pace, then machine learning library and graphics. All right. So you can and you can talk to Spark using these programming languages. All right. Any questions before we start? Next is that the core idea in yes, Sneha, you have a question. So regarding your question, you can drop me an email. All right. And when it expires, you will see the extend now button and you can extend. All right. If it's just for 1 week extra or 2 week extra, we will anyway extend everybody's. We will extend everybody's session from 2 weeks from now. Everybody's CloudX Lab for from 2 weeks from today. Okay, so no worries. All right. Now, the core idea behind Spark is the HD, the resilience distributed data set. It's essentially a data set that is distributed across multiple computers. It could be either the pointer to the actual location of the data or it could be actual data. Okay, so a resilient distributed data set is essentially a data set that is distributed across the cluster. Okay, so by default, it is kind of a every basically it is kind of a mapping between the actual data and the partition. These are called partitions. So when you load data into uh, into a RDD. Okay, when you load RDD, load a data into RDD, what happens is each partition get mapped to a particular section of the data, and this is where the data locality lies. So this distance should be as much closer as possible. Okay, and so basically, first idea behind RDD is it tries to keep the pointer to the actual location such that the data is as close to the distance between the RDD partition and the actual data location should be very small. Okay, this RDD can recover from the failures because because Spark knows how to create RDD. It keeps a track of all the commands you have provided in order to create RDD. Okay, so if one particular partition fails, Spark can quickly recreate it on another machine. All right, so that's the main idea behind RDD. If there is certain data you want to retain in memory, you can do a cache and it will be retained or persisted in the memory. And it supports two kind of operations, which is two basic general kind of operation. One is transformation and action. Okay, and RDD is a kind of read only in the sense that you do not alter the partition. Instead, you create a new RDD. All right. So last time we demonstrated how to load an RDD either from the memory like this or from the text file like this. Okay. Next we discussed about was how to run the transformations. Okay. So a transformation, there are many kinds of transformation. One of the most common one is map. We could run a map transformation, which essentially translate every element of RDD into something else. Okay, so the way we demonstrated last time was, okay, let me just open the last time's file. Okay, all right. Okay, so now we have a, all right, this is what we did last time. We basically loaded a file. Okay, and then we counted vowels in that. Okay, so how did we count the vowels? We basically executed this function called count vowels on every element of the this file. And what is each element? Each element means an individual line of the file. Okay, so this particular function will be executed per line, and every line of this file is going to be passed to it. So lines.map some function means execute this function on every element of this RDD. Okay, and pass every element as an argument to this function. Okay, that's what a map means in Spark. Okay, all right, I'll come back to your question, Ashok. So this is what we discussed last time. All right, so all right. So this piece of code is clear to everyone, where we first create an RDD called lines by loading this file, and then we do the map over these lines and execute this function via map. So what does map do? It executes this function against every element of the line, and then we tested it. All right. Okay. So a question from Sukhvinder is, let me just open another window and write your questions. This is another window for today's questions. Okay, so here we go. All right. So a question from Sukhvinder is, what is SC? SC is Spark context provided by PySpark console. Okay. This is the entry point. This is the entry point to Spark. Next is, what kind of architectures are we having between partition and RDD? So a partition contains many elements of an RDD. Okay, and you can say that you can actually say like this. Okay, so RDD is made up of partitions where each partition could be located on one computer, and then every partition is having a list of elements. Okay, so you can think of an RDD as big list where some elements of this list are on one computer, which is called a partition, and some elements are on another computer, and that's called partition. Does it make sense? Is that what you're looking for, Ashok? Okay. Next question from Suraj is, when an RDD is created, it is kept in the memory. So when a partition goes down, from where does the RDD recover the data? Okay, let me take a good example for you. Okay, let me just take this example. So let's look at what does it mean. Okay, so it means lines equals to sc.text file, correct? Lines equals to sc.text file. This particular line is creating an RDD called lines. So it creates an RDD. This statement creates an RDD, and this RDD is distributed over the cluster. Now imagine that one of the partition has gone down, correct? But so Spark knows that this partition was created as a result of loading data from this file. Okay, so it can load the data again from the same file if a partition goes down. Does it make sense, Suraj? Did I answer your question? Right? So Spark knows that knows this statement. Okay, and in case we have persisted lines data, it'll again load the same file and load the partition which has been lost. Or think of this way, we are saying vowels in file equals to lines.map. So vowels in files is also another RDD. Now Spark knows that vowels in file was created as a result of running count vowels against lines, right? So that particular section of the data will be again created by running the map after loading this text file. Sukhvinder's question is, that means every transformation is RDD. I would say this way. So every transformation leads to an RDD. Okay. A very good question. Again, a follow-up question from um, okay. A follow-up question from Suraj. What happens when we executed an action and then we do another transformation and then the partition goes down? So when the next time the action is executed, partition will be recreated. Okay, by executing the same action. All right, very good question. So let's take this example. So take is an action, right? And then after take, also please keep in mind that right now, when we are normally loading a text file into lines, we are essentially creating we are not really loading the data into the memory. Okay. Spark is just making a note of how you created lines. Okay. Spark will start executing things when you call an action. So if you are calling a transformation like map on an RDD or something else, Spark will not be creating the actual data. It will just keep noting that, okay, you wanted to run these transformations. Unless an action is done, like take is done, it's not. So imagine that we executed an action like take, and then we kept it in the variable. So take would always result in another data set physically or in local variable, right? So another generally action results in an action results in another variable, another data set. Okay, so action does not usually result in an RDD. Okay, so does it make sense to you now? Sundar's question is, was the use of take? Take it just to displaying 10 elements from this particular RDD. Take is an action. A question from Ashok. So if a partition goes down in between some process, in this case, the partition recreate, an entire job will start from the scratch. Correct. So if let's say we are executing take and some part of lines have gone down, so it will recreate that portion. If required, it will rerun the job or it will fail the job in case let's say it's in middle of execution and some nodes fail. So Spark will actually fail rather than keep on retrying. MapReduce keep on retrying while Spark generally quickly gives up to give a better feedback. Sundar's question is, what is giving value 10? 10 means we want to take out 10 elements out of this RDD. RDD is made up of elements and those we want 10 of those elements. Right now in our context it is number of vowels. If we say line.take 10, we get 10 lines from the file. First take 10 lines. A question from Prabhu. In new version of Spark I had RDD is replaced by data file. No, they are trying they are basically using some other vocabulary as well for RDD, but RDD is not replaced by data file. So a question from Prabhu is that RDD plus schema equals to data file. Yes. So uh, you can basically save an RDD to a text file. Okay. And this, there are many save functions. Some of them actually take schema as argument. All right. Did I make sense to you, Prabhu and Suraj? Great, great. All right. Now moving on. So we were talking about transformations and action as we talked last time. So action is something which make things happen. Example of transformation is map, filter, flat map. What does map do is it takes every element of the RDD and run this function against that element. Okay, by passing every element of the function and do it distributedly on the cluster. Okay, and the filter returns a new RDD formed by selecting only those elements for which this function is returning true. Okay, for only those elements for which this function is returning true. Okay, do you want me to show you the example? All right, all right, let me open my LMS. A question from Prabhu. So we can save files in RDD or data file format. So RDD is not really storage, but RDD can be saved into a file. Okay. So Prabhu's question is, so can we save files in an RDD? So we can load data into RDD and then we can save RDD into whatever format do you want. And this ETL can be done using Spark. A question from Ashok. Uh, Vowel in file seems a collection that have n number of value, and in this example we need 10. Yes, a very good question. Okay, so here is another good question from Suraj. When we loaded data into RDD lines, yes, when we loaded data into RDD called lines, you said that, just a second. All right. Now, question is, when we loaded data into RDD called lines, you can see lines. You said that the RDD used the line feed to delimited each value. Yes. So a lines is essentially, if you think of it, like a big array. So it separates this sc.text file. This text file function will load the data such that one line is separated by another line. There are two elements. So lines is an array. So this text file is converting plain text into an array which is distributed over multiple computers. All right, which is, kind of, first sc.text file tries to load the data. Okay, data as in it tries to first map, and then when the actual process is run by the cause of action, then it first loads the data in the form and then split it by new line and then create those elements. Right. Okay. Further question from Suraj is, if there is no new line or there is no line feed in the entire text, then Will the whole text be loaded into one single element? Brilliant question. Yes. So, this is one of the causes of concerns whenever you do the distributed programming. So, what happens is, in case the way you are loading RDD, it's not distributing the work evenly across the cluster. Generally, your job might fail. Okay, and this is same is true in case of MapReduce. You're feeding into, let's say, Python program, and there was no new line. And this actually happened, Suraj, in case of our MapReduce, usual MapReduce. Somebody just echoed up, basically concatenated the same file with itself again and again, and the file was around 50 MB, but file was actually more than 50 MB, but there was no new line in that file. Okay, and he was trying to run a Python streaming job for MapReduce. So all of the jobs were failing because it was creating a very huge line, and that huge line was overflowing memory every time. Same is true in case of Spark as well. Okay, so all right, so yes, very good question. All right. One of our student was, he was flustered by MapReduce. It happened, I think, in last batch or something. And basically, the whole cluster, none of his map job was working because he was trying to do everything on a single map task. Okay. So this is exactly why we need to understand the process of MapReduce. All right. Great. Great set of questions. Okay, so let's load the file again, and but before that let's launch PySpark. This is the console of Python in which you are provided with SQL context, okay, Spark context called SC, and here, okay, so this lines is right now an RDD. It's a map partition RDD. There are many kinds of RDDs, and map partition RDD is one of those. Next is let's define the function. Okay, so we defined a function which basically counts how many vowels are there in any string. Okay, all right, you can see that it is counted good. Now in these lines, what is there in the lines? Let's just take first 5 elements and check. Okay, you can see that every element, there are 5 elements. Every element is the line from the text file. Okay, now let's say we want to count the number of vowels in every line. So what you do is you say vowel in files. Okay, now we are saying run the count vowels against every line. Against every line, it is going to run against every line. Count vowels is going to run, and whatever is the result of count vowels is going to get stored in vowel in file. Okay, but nothing is there right now unless we execute an action. And what is the action we are going to execute? We are going to execute the action called take. You can see that have just done take first 10 elements. Okay, so we have been successfully able to run map map over the elements. Good. All right, I'm hoping that things are clear so far. All right. Let's say out of these vowels, we just want to keep, out of these vowels, we just want to keep, and let me just also copy the code. Okay. Out of these vowels, what I want to do is I just want to keep only the even numbers. Okay. I want to keep only the even numbers. So all I do is I write a function called is even. Okay. Is even. And whatever number you pass to it, it basically return number percentage 2 equals to 0. Okay, anything, any number divisible by 2 is just, is basically calculated like that. Okay, so here we are. All right. Now let's try to execute this function is even. Let's test it. True, false. Good. Now the next step is we are going to, okay, next is we are going to execute is even against vowels in this. So we are going to say is only even vowel count equals to vowel in files dot filter. And what is the filtering criteria? This particular function. So you can see that we are passing the name of a function as if it's a variable, because in Python that's the way it is. Now right now it has not done anything because it's a transformation. So now let's run take on this. Instead of take, we could have run save. That's also good. Now you can see that only the only those line counts, or the word count of each line has been, character count of each line is printed, which are even. Good. Next question from Ashok is that if we execute take 10, it is going to execute again. Yes. You can see that every time I run this, the whole process starts again. Good observation. All right. Next is, that is a transformation. Now sometimes we need to run action, which returns the value to the driver. Who is driver? From where the program is being executed. Every Spark program is run on a computer, as in there is a node which is a launcher. Okay, launcher as in the one which gives the commands like map and filter and all of these. So that node is called the driver. From the driver, the whole process starts and it ends. Okay, so basically an action returns to the driver, while a map function either created another RDD. Okay, map function, sorry, transformation generally created another RDD, while an action is returning the value back to the driver. Okay, a question from Anian is, take and filter are inbuilt Python function for Spark? No, they are provided by the Spark library. Okay, they're provided by the Spark library. So right now when we are doing here, so whenever we are saying lines equal to this lines is an object, which is something Python has provided. Now this object has all these functions like map and everything, which are part of Python Spark, basically PySpark library. All right, does it make sense to you, Onion? Okay, good. Next is there are many kinds of actions. One of them is reduce, and reduce is something very, very important. Okay, I want to show you how does reduce work. And okay, so reduce actually works the way we had explained last time as well. This reduce actually work by taking two values and combining them. For example, I want to count the total number of vowels in this file. Okay, so if I have to count total number of vowels in this file, all I have to do is I have to sum up all the values in this vowel in files, right? Because it contains all the vowels. Correct? A question from Anian is, we should know all the functions in order to use it properly? Yes, you should generally know all the functions. It's not that difficult, they are on the same pattern. Okay, now let's try to basically count number of vowels. Okay, so we have vowels. Okay, so this the variable which contains the count of vowels in every line. Now we want to sum up all of these values. So what you do is we define, let's say, a sum function which takes two argument. Please note, which takes only two argument and returns summation of the two. Okay, let's test it first before sending it to Spark. So right now we are just testing it in Python. Now it works fine. It is giving us right results. So let's execute it as a reduce function. Okay. So right here, I would like to take a small digression. So when you say reduce, okay, and we are saying my sum. We are passing a function to Spark. We are passing a function called my sum to Spark saying, hey, here is a function which can reduce two values into single. Use this function to reduce the full array into single value. Okay, that's what a reduce function does. Okay, it again and again and again and again applies this function. It again and again applies this function on two values and converts the whole array into a single value. Okay, so I'll show you. So how does it work? Okay, so let's say there are okay, let's say there are these one, two, three, four, five elements in your RDD. Okay, this is your RDD which is containing. It's not wavy. It's just different elements of the array. Now, your MySum function will be applied on these two functions separately on one machine and this on another, and then whatever is the result, these two values are going to be summed up. Okay, and next, once that is done, these two values, this one and this one, they will be summed. Okay, so this is how it will happen. Same function if I have to draw the same function. Okay, if I had to draw the same function is running here, running here, running here, and again also running here. So you can see that a function my sum is going to be executed how many times? One, two, three, four, right? This is going to be executed 4 times. So it's like n minus 1 times. If there are n elements, it's going to be executed n minus 1 times. Thank you. That's right, Parvez. All right. Now, it brings us to a point that we cannot use certain functions in the reduce, right? We cannot use all kinds of functions in reduce. We can only use very selected the functions which are commutative and associative in nature, which means if the same function is applied again and again, the result should be same. For example, max, min, summation are good, but average is not a good reduce function. Average is not a good reduce function. You can see it by yourself. Now try to compute the average of these 5 values. Okay, and the value will be how much? Anyone? Okay, it is 10 plus 11 plus 30 plus 3 plus 6. Okay, you can see 60 and then 5. So the average is 12. Now, if we try to go by this route, so first the average of 10 and 11 is how much? Anyone? It would be 10.5. Good. The average of 30 and 3, anybody? 16.5. That's right, Suraj and Vivek and Sukhvinder. Okay, it's going to be 16.5. And then if you sum up 16.5 plus 6 and you divide it by 2, so how much is it? 11.25. Correct? And then 11.25 plus, okay. So the overall value is 10.875, which is not correct because the value was supposed to be 12. Why? Because average is not suitable, because average of an average of the subsection of an array is not equal to the average of all elements. Make sense to you? So average is not commutative and associative in nature. Alright? So count, collect, take, all of these functions are very similar to take. Alright? Uh, do you want to take a break or something? Okay, let's take a break and yeah. All right. So I'm back. Should we start now? All right. So yeah. All right. A quick question from Prabhu, that when will we get our completion certificate? Generally, we give the certificate after the course finishes and after you submit the project. Okay. All right. But since you have already submitted, we will send you the certificate. All right. Now, here's an example run of the line length computation. Imagine that you had to compute the line length. Okay. So, and this is your file which contains all the lines, and you have loaded it in an array. Okay. So after the map, let's say after we map each line to the line length, we'll get these line lengths, and then the summation will happen at the reduce part. Okay. So using a map function, we first computed the line lengths and then did the summation. In our example, the one which you were just running, instead of line lengths, we were counting vowels. Okay, the philosophy is same. Now, this was happening on a single node. Let's say the same thing has to be done on multiple nodes parallelly. So on node 1, we get line lengths. Let's say the same array is distributed on 3 nodes. So first three element on first node, second element and fourth element is on node 2, and fifth and sixth element is on node 3. Okay. So after the lengths are computed on each node, okay. So lengths for first three elements are computed on node 1, and lengths for this partition, second partition is computed on the second node, and third partition is computed on third node. Now the game of summation, the reduce function, which will sum up these values, will start on all the nodes parallelly. On node 1, it first computes the summation of 11 and 9. There we get 20 and then 24. Okay. Now node 2, it doesn't have to do anything, and node 3, the computation will happen, and similarly we got 24. Now, right now, if you see, the reduce function was executed on all the 3 nodes, while reduce function will also get executed once on the driver node. Driver node is the one from where you're launching the program. Right now, we're launching the program from this particular machine, e.cloudxlab.com. That is our driver node. Okay. Now, on the driver node, what will happen is the line length value is 24, which is from the first node, 24, then 14 and 24 from third node. Correct? And then the summation will start happening in the same way. First, these two values, and then the summation of these two, right? These two values result in 38, and then 38 is summed up into 62. So this is how the distribution of the work happened. So as much as possible, it tries to avoid doing calculation on the driver node. Okay, most of the work is transferred to the node 1, node 2, node 3 parallelly. Okay, Ashok's question is, Sandeep Giri ji, it should be 11, 10, not 11. So 3 plus 4 plus 1. How much is this? 3 plus, okay, that's right. It should be 10. That's correct. So let me just make it good. Good observation. Thank you, Ashok. And then we can sum it up. All right. All right. So that was the example of reduce. Okay. Now, sometimes you want to do the shared variables, as in if there is a particular piece of data that you want to transfer to all the nodes, copies of the data you want to transfer to all the node, for that you use broadcast variables. So you broadcast an array and that will be made available on all the nodes. The other concept is in Spark is accumulators. What does accumulators do? Accumulators essentially are similar to progress reporting in Hadoop. Okay, accumulators basically gather the data from all the nodes parallelly. Okay, so if all the nodes have to report something back to the driver node continuously, it can do so using accumulators. Okay, so whatever it emits, each accumulator, whatever it emits, it keep getting summed up into a single variable, or it can be basically it's a great way of communicating back to the driver node that this is what is going on right now. All right. So, okay. Now, let's take a look at the word count example again. Let us say we had to remove the common words. Correct? If you want to remove the common words, we can send that as um, we can send that as a broadcast variable and then remove the common words. Okay, here is the standard word count problem, as in we first loaded the text file, then we converted each line into words by creating a function that splits each line into an array and then calling that function via flatmap. Flatmap converts one variable, one value, one element into another. Flat. If there are 10 elements, sorry, sorry. So usual map, the one map function which we were running, it generates the new RDD of the same size as the input RDD. Okay, but flat map can convert a single value into many values. Okay, so this is what is happening right now. So a single value as in single line is being converted into many words using flat map. Okay, now each value need to be converted into key value format, so we use 2kv function which we have created here, and then once that is done, we after we have converted each element, each word into word comma 1, then we use reduce by key. Okay, then we use this function called reduce by key, which is essentially summing up values. That's it, and this will do the word count for you. All right, now if we have to use accumulator and broadcast, this is how we are going to use accumulator and broadcast here. Okay, first we import the text. Second, we broadcast the common words which we don't want to count. Okay, and then also we create an accumulator. Okay, also we create an accumulator. So first, using flat map, we convert lines into array of words, and then over that word we remove we re, clean up the data by removing all the special characters and then convert that into lower and so on. Okay, and then we have used something called a filter function. Here the filter function is essentially removing all the words which are not in common dot value, meaning this broadcast variable. Okay, also this filter function is adding some value to the progress. Okay, so that's it. And here basically once that is done, after filtering the data whatever we have, we can print it by using take function. And yes, also we can save the same thing into a file using save as text file. All right, so this is accumulator and broadcast variables. All right, does it make sense to you? All right, so try to do this second part by yourself. Okay, if you get stuck, take a look at it. It should work afterwards. And all right. All right. Now we want to talk about something very, very important. Okay. Something which is very important called Spark streaming. So, what does it mean by Spark streaming? Or first, before we jump into the idea called streaming, let's first understand what does it mean. What does it mean by saying streaming? Streaming is a very heavily abused word in the software industry. So, streaming means showing the movies like Netflix and YouTube. Streaming means passing data through the a function, such as in Unix commands we use filters and we stream data. For example, we have a tool called SCD in Unix, and SCD means stream editor. Okay, so that's also streaming, as in passing data through a program, right? So, but here we are going to talk about stream processing. What does it mean by stream processing? Let's talk about a real use case. Okay, let me talk about the project which we recently did for Dell. Okay, in that project, what we were doing is, on one end, the data is being created by Dell systems. And what is Dell Systems? Basically, Dell has a website from where people can place an order. And when an order is placed, there are many things that happen in an organization. And all of that happens via an idea called a message queue. In any large organization, whether it's an e-commerce firm or it's a usual enterprise product firm, everywhere there is a concept called event bus or a data bus in an organization. Okay, so anytime an order get placed on Dell's website, the event get pushed to this queue, to the message queue or event bus. Message queue and event bus, they both being used interchangeably. So when an order get placed, the order is broadcasted into the message queue, and from the message queue there are many listeners to the message queue. One listener is um, one of the listeners is, say, fraud check. It checks for the credit card whether the credit card is valid or the transaction is valid. Second one sends. Second one, there would be multiple listeners for the same order. Second one basically sends an email to the delivery and shipping people. Third one might be listening to basically talk to the bank account and start delivering the order, or send the email update saying that your order has been placed. So there are many listeners for every order that get processed. Also, whenever the order shifts from one state to another, as in earlier it was just processed, then dispatched, then checked, and then out for delivery, and so on. There are many states why during the life course of. So the objective of the project was to show in the real time how many orders are in what shape, whether they are dispatched in the current scenario. What is the real number that represent? I mean, how many orders are there in every bucket? Okay, how many orders are there in every kind of status? So for doing such kind of work, specifically when there is a huge data, you need to do something called stream processing. It's more or less like a real time data analysis. A lot of data is flowing in the real time, and you have to produce analytics on top of it, which is available almost in real time. Okay, so this is stream processing. Stream processing is a very important subject in today's time. Okay, so there are many solutions, and right now we are going to talk about one of the solutions called Spark Streaming. Okay, any questions at this point? All right, so generally, in case of stream processing, there's a continuous stream of data that is coming in, and that continuous stream of data is might be coming from message queue such as Kafka, 0MQ, or it could be coming from a file system such as HDFS, or it could be coming from the engines such as Flume, or it could be coming from the Twitter kind of data source. Basically, anywhere there is going to be a continuous stream of data. Now, the other important aspect about stream processing is that it runs forever. It does not stop. Unlike our usual programs end, it does not end. It keeps listening to the data, and whenever the data is not available, it waits. It waits for the data to be produced by any of these inputs, and then the moment the data is available, it processes it and sends it to HDFS or databases or any other dashboards. Okay, so essentially, Spark Spark Streaming is essentially a library on top of Spark, and that library is called dstream. And what does it do? It actually does a very clever and simple thing. For every second of data, it creates an RDD. For every second of data, it creates an RDD, and on top of that RDD, it keeps on executing your functions. Okay, that second could be 2 seconds, 5 seconds, or anything. It's called the window size. Okay, so Spark Streaming receives live input data on one end and it divides it into batches. Okay, and then these batches are nothing but an RDD. Every batch is an RDD, and inside every batch there are there's data per second or per milliseconds and so on, and that all is going to be distributed across the cluster because RDD is distributed across a cluster. So for every input, periodically it keeps on creating the RDDs, and on that RDD it keeps running your programs, your MapReduce programs again and again. All right. So this is how it looks like. On one end, there is a data coming in, and the RDD is being created at time 1, time 2, time 3, time 4. And on each RDD, your MapReduce will get executed. Okay? All right. Sometimes you might have to work on top of this kind of a D stream, and you might want to combine multiple values from multiple times. In those cases, you could do the window operation. All right. So the example is very simple here. Okay. Prabhu's question is Spark streaming only used on live feed of data? That's right. So whenever you have to process live feed of data and you're okay with a delay of a second, then you should go for streaming. If your delay of microseconds or milliseconds is only acceptable, then you should go with Storm. All right. Okay. So we are going to basically walk through an example. So first we create a connection. Okay, and the connection looks like this. Right now it's only in Java, but you can also have it in Python. All right. Okay. So you open the streaming context like this, which means you're going to listen to the data every second or so. Okay. Here we are saying that create a D stream for a duration of 1 second, meaning it'll absorb the data for every second and create an RDD. And then on top of on top of every D stream, we can execute our usual map reduce functions. Okay, we can reduce our map reduce function. So essentially what's happening here is it's going to run the word count for every 1 second data. Okay, for that we first created the D stream, and on top of that we once we created the D stream, on top of that we started executing our flat map. This flat map essentially splits the data by space. That's it. And then once that is done, we are calling. Okay, so we are basically converting the word into key value, and then we are summing up their value. You can see that essentially whatever we did earlier for word count problem, right now we are doing it for 1 second's data. We are doing that for 1 second's data. All right. So for from time 0 to 1, the words from 0 to 1 get printed. by all of these operations and so on. Okay, do you want to see a demo of Spark streaming? How many of you want to see the demo of Spark streaming right away? Okay, great. Looks like everybody is interested. So let me just, all right. So I'm picking up my Spark class. All right, here is the slide. Okay, so first of all, let's create a connection to the service. Okay, so the way we create a connection is by using this kind of syntax. You can see that. Okay, and second, we will do the usual split the word and do the word count and so on, and then print the data. That's it. Print the data. Okay, and once we are done with the printing, then once we have finished writing the whole code, then we say start the streaming process and then wait for termination. Okay, which means it is going to run for full time. Okay, so I've already written the same thing in a file. Okay, so all right, so let me just see if, so you can see ls Hadoop fs minus ls data spark. So there is this file called Spark Streaming example. You can copy this to your local and then can start working on that. Okay. So I've already copied that file spark streaming.py and I would like to show you this. Is it clear to everyone? If you are not comfortable with Vim, you can actually open it in the Nano. Okay. So here you can see that clearly that we first, here we are importing whatever PySpark and everything. Here you don't get SC Spark context. You have to create a Spark context. On console, you get this Spark context for free. Okay, without doing anything. And then here we are saying create a streaming context on top of Spark. And then we are saying on top of a streaming context, saying open the connection at this port. Okay, it's going to, okay, it's going to connect to this particular port to listen to the data and then start processing. Okay, so first of all, let's run this. Okay, so if you look at the photo here, it shows that we are basically, this program is going to run forever trying to read the data from this particular port 999, and then we start producing. So this side it's a listener and this side it's a producer. Okay, so let's first run our Spark streaming. Okay, that's it. So I've submitted my Python program to Spark. So right now it's essentially listening and waiting for the connection on 999 port. Okay, it says that could not connect and it failed. Now, let's open another terminal. Let's open another terminal. Okay, because we have started the stream process. This is a streaming process which is trying to connect to a live data source, and that live data source is not right now available. Okay, so let's try to create the data source. So I'm logging in, and okay, now we have two terminal, one here and other here. Let me just put it back here. Okay, ouch. Okay, so this is the one where our receiver is running, the Spark process is running, and this is where we want to start producer of the data. Okay, meaning with this respect, this side we want to start, this side is already running here. Okay, it's giving error that could not connect to 99 port. Now let's say we are using a command called nc. What does nc do? Nc creates a quick server for this kind of work. So I'm saying nc listen to this, and then I start typing. Okay, so what exactly I'm doing right now? I'm producing data, and here is my Spark streaming continuously doing the computation. You can see that it has done the computation. Okay, now in case we want to generate really high amount of data, let me try to do something called yes command. What does yes command do? Yes command produces lots and lots of Y's, and we could do things like pass the output of yes command to ANSI. What is happening right now is my yes command is producing the real-time data, which is going to ANSI. ANSI is basically going to start a server at this particular port and keep on producing that data, and our Spark streaming job will go to connect our ANSI. So right now you can see that now. Do you see that? Now, here you are going to see lot of records. Okay, all right. Because right now I am having lot of screen blindness. Okay, let me hide the debug message. So quick and dirty way is to use this kind of redirection, meaning send everything from uh, the error messages to the dev null. Okay, now let me start the producer again because the consumer has gone down. Now you can see every second it is going to count number of Ys. Wow. All right. Now I think it's working. And how much is the delay? Right now, oh, Now you can see. So every time we are running, it's uh, every 10 seconds, every 10 seconds, this Spark streaming is printing number of words it has encountered. Now let's start producing some real data. Okay, let's start producing some real data so that in 10 seconds it should be able to do the calculation. Now you can see that in last 10 seconds these many y's have been encountered, which is how much? 3.3 lakh y's. Okay, now since we have increased the window to 10 seconds, that's why it's going to take a lot of time to do the computation. Okay, so how much time it has taken already? All right, okay, so looks like it's going to take a little bit more time. Let me decrease the window size to 1 second. All right, let me change the time to, okay. So now let me try to show you something again. Suraj's question is, how do you stop a program in between? So you can just press Control C. It's just that it got really involved. Okay, so let me just start executing this. Now I want to just change it to 1 second. Okay, all right. So I'm again running the Spark streaming program, which is going to run every second. You can see that every second is printing how many words it has encountered. Now let's pump in the data from the other side. So here I'm just pumping y again and again into the same port. Now you can see something interesting here. You can see that per second it's encountering 1.7 lakh y's. You can see that. So it can handle so much of data per second. 4.2 lakh input records. You can see that 6 lakh Ys have been encountered in a single second. This is called stream processing. On one hand, we are producing the data here. This is where we are producing the data. On the other hand, we are consuming it. No, it's not adding to the previous results. Otherwise, the second one would never be smaller than the previous one. So you can see that this is the kind of data you handle in case of real time. And we are able to do it using just 4 or 5 nodes, using just 5 nodes for the computation. Sounds interesting to you? All right. All right. So yeah. Okay. Leela's question is, how does receiver know that the feeder is on 999 service? Good question. So if you take a look at the file which we modified, okay, if you take a look at the file which we modified, let me try to take a look at, you can see that here I'm saying that 999 port. So, okay, good. So that was a quick example of stream processing. All right. So I was trying to demonstrate to you that how powerful Spark's streaming is. We were able to churn 5 lakh records in a second. Okay. A quick question from Sundar is, what is the use of lambda? Okay, it's called lambda. Okay, lambda is like anonymous function. Instead of defining a function outside and passing it in the next step, you could define the same function inside a function call. All right. So that is the use case of lambda. Lambda is essentially an anonymous function. Okay. So question from Parvez. It seems Flume plays major role in Spark streaming. Not really, but it does play a role. Okay, so Flume is a real-time data producer. There could be many similar systems like Flume which do uh, the data production. Okay, question from Vivek: what effect will increasing number of threads have? If you increase number of threads, Spark actually takes care of the multi-threading. So whatever map function you run, it will not only be distributed but also be parallel. Meaning, if your one computer is having multi-cores, then map function might be running on the same machine parallelly on the same partition. That means Spark utilizes not only the memory but also the CPU really, really effectively. Okay, I think I missed your question, Asmeet. Yeah, you're right. Let me just try to answer your question. A question from Asmeet is, can I schedule a job in Apache streaming? Yes, you can do. So, whatever we have done just now is we submitted the job, but right now it does not provide you the scheduling engine. It does not provide you like Uzi, a scheduling engine. So Vivek's question is, for computation intensive programs, we should use more thread. Yes. More thread and more computers. More CPUs, as in, yeah, more cores and more computers. All right, good question. So, yes. Now going back to where we were. All right. So this is how the whole process of running the streaming job. All right. So all of you, please try to run the streaming job the way I have run. Okay. Do not skip it because this is a very crucial part. All right. Next is the storm part. Okay. So there is another stream processing engine which is quite popular. It's called Apache Storm. It's for real-time analytics and online machine learning. So whatever machine learning we talked about, it it basically does the relatively static data. But if the data is really high, then you would like to, and if relate data is not static and you want to run machine learning on top of it, you might want to go with Storm or Spark. Now, the difference between Spark and Storm is Spark is relatively newer than the Storm. Okay, so you can see the differences. So in Storm, you process one record at a time, and in Spark, what was happening? We were converting the data into batches of data. Okay, so in Spark, we have many batches. In Storm, we have one record at a time. So latency in Spark is few seconds, while latency in Storm is part of a second. Latency is in time taken to do something. Okay, so the with respect to the fault tolerance, okay, Storm might run a particular piece of data through a code multiple times. Okay, and in case of Spark, it's only once. Right? Now, the implementation and API does not play too much of a role in making a choice. The most important part is sub-second and few seconds. Okay, if you cannot wait for few seconds, you should generally go with Storm. Okay, if you are okay with a little bit more time, then you should go with Spark. All right, so this is a general comparison. You can go through the details. All right, a quick one-liners for every SQL. So we'll just go through very quickly the all available NoSQLs as of today, because every now and then, every now and then you will face these challenges whether to use this database or that database. Okay, so I'll take you through multiple kind of databases, and then okay, then we'll go through the project. Okay, so one of the NoSQL databases is Redis. It's an in-memory database and it's best used for rapidly changing data with a foreseeable data size. Now, the main important part is that it keeps the data in the memory. The moment memory gets full or you got other priorities to give to the memory, then Redis will not be something which you would like to use. Okay, so for rapid, where basically it stores the data in the RAM. Although a copy of the data is in the disk, but still all of the data is in the RAM, which means it makes the RAM scarce. All right. Next is I think I missed. Yeah, I missed Sukhvinder's question. So Sukhvinder's question was so you just need to know the process. Rest everything is in the libraries. That's right. All right. Now the other NoSQL which is quite popular is MongoDB. MongoDB. Now, MongoDB stores data in objects like this: first name, last name, age, address contains further objects, and so on. So, it's best used if you need dynamic queries, if you prefer to define indexes, not MapReduce functions, if you need to go for a good performance on a big database, then you should go with the MongoDB. All right. So basically, the thumb rule is that while if you your data is little bit like a document or a big object, then you might go for MongoDB. Okay, when if you want to store data in the form of documents, in the form of big objects. Yeah, this is JSON format. That's right, Ashok. This is a JSON format. And all right. So if you want to store your data in the form of like SQL tables, you should go with Cassandra. Cassandra provides something very interesting. It's called tunable consistency. Okay. And that's very important. Very important. The other feature of Cassandra is it more or less looks like a big table, and it it basically has a query language. So it makes a people who are coming from the usual SQL backgrounds life easier. Next is HBase. We have already talked about HBase. Whenever you have billions of rows and millions of columns, you should go with HBase. Okay, and you if you already have Hadoop cluster, otherwise if you don't have a Hadoop cluster, then there's no point of using HBase. All right, so that's pretty much with respect to the databases. So similar to HBase, you have Accumulo, which is essentially a big table with cell level security and so on. Okay, take a quick look on this link to get the difference between various databases clear. Yes, all of these are open source. All right. So that was a quick introduction of various NoSQL. So Redis keeps in memory. MongoDB has the document orientedness. Cassandra is almost like SQL, and no, HBase is for billions of rows and millions of columns, and for the cases if you have Hadoop cluster already. All right, it'll be there in the slides. Okay, take a look. I'm passing the link to everybody. Parvez is saying some info about green pulp. I have no clue about green pulp actually. I'm hearing it for the first time, honestly. All right, so that was some quick overview of NoSQLs. All right, now I would like to go with the project details. All right, so project is comparatively simpler if you just want to do it in a very straight manner, but there are many deviations possible, and I expect you to work on the deviations. All right. So the problem statement is very standard statement. It's called the sentiment analysis. The objective of the exercise is to do the sentiment analysis based on the Twitter data, which you can download from Twitter. Okay. So the step which we are going to talk down is basically the primitive strategy for sentiment analysis for a movie called Iron Man using Hive. It is up to you whether you choose exactly same steps or you use different strategy altogether. Okay, there are various deviations possible. For example, you could use pig instead of hive. You could use completely different algorithm to compute the sentiment. Right now, what we're going to do is in this exercise is we are going to compare each word against a dictionary. And that dictionary tells whether a particular word is negative, positive, and so on. Okay, so we are going to compare each word against the dictionary and find out each word's worth, and then form the opinion about a tweet, whether it's a negative or the positive. All right. There are many more deviations that are possible. Okay. So first of all, you log in into Hue at this port. Okay. Does it work? Okay. Now, once you have logged in into Hue, you log in into your own account. Password error. Let me copy paste again. Okay. So once you have logged in, you go to this particular file where all the data is located. Okay. And then follow the example query. We have provided you a sample query. You are encouraged to create a new kind of query instead of just following it. Okay. The general idea would be you first follow whatever is told here and then you plan for deviation. Okay. So you create your own database, make a copy of data to your home folder, and then follow the query located at this place. Okay. So you run these commands after logging into the server, copy this into local folder, and then also copy the sentiment file into your home folder, and then you start running these commands. Okay, first of all, you set the hive sql1 result keyword as false, and then before that, before running hive, you run the inside the hive command itself. First, run the command called hive and then execute this, then this, and create the table like this. Okay, what's happening is in this table, it first loads the data from the input folder. So you can see tweets raw is nothing but the data at this location. Okay, so we first loaded all the tweets using the JSON survey which we have supplied above, and then you load the dictionary, and then you load the time zone, and then next thing you do is you combine the tables. You join the two tables, okay, and you'll get the result. I'll show you this. So we are joining first with the time zone map. Before that, all right, here. Okay. Yes. So first of all, you create these basic tables, and then, okay, then we have simplified it here. Okay, and then you can, okay, then you can clean the data cleaning the data. So you can see that all of these are views. Okay, all of these are views. So after we have combined the time zone with the tweets, then we start breaking the tweet into words. Here we are exploding the sentences into words. And once we have done breaking that, then we join that with the dictionary. Okay, you can see that we are joining here with the dictionary, whether a particular word is negative or positive. You can look at the dictionary located in the same folder. Okay, and so on. Okay, once you have joined with the dictionary, you can form the opinion about the whole tweet by summing up the polarity of individual words. Okay, and once you have summed up the polarity of individual tweet, then you can represent it using the UI. So you follow this documentation clearly. If you get stuck, let us know. It should be very straightforward process for you. All right. So that's pretty much about the project. All right. So just go through the project step by, and first you try to do whatever it is. And once you submit your report, as in these are the things you have done, along with your Excel sheet, if you're using Tableau, please share the Tableau report. And if you're using the Excel sheet, it's also good enough. Please share the Excel sheet along with the screenshots. Okay. Yes. So first of all, you go here, go to the session, and then go to the project discussion. Okay. Session number 11, and then project discussion. Okay. So you can all locate it in that. Anyway, I'm copy pasting it, and you can start using. All right. So that was pretty much with respect to the course. If you have any query, feel free to stay connected with us, and we would be more than happy to stay connected. So also you can send me a LinkedIn request so that we would stay connected. All right. So I would unmute you one by one. If you have to say anything, feel free to say. Okay. I'm going to, yeah. So the project is due on, all right, the project, generally project is due on 1 week from the day we declare the project. Okay. So you have close to 2 weeks. You have close to 2 weeks to submit your assignment and submit the project. All right. Yes, the assignment. Yeah. So Vivek, I have reviewed the assignment. So yes, I think you are not getting my emails. I think, yeah, I have gone through your assignment. You have done a very good job. Sundar's question is, where can you find the assignments? You can go to Novik Data's course detail. Everywhere you can see on the first one, you see the quiz and so on. Okay, so you have to go session by session. Okay, you can see map reduce subjective questions. Then there is one more assignment. Okay. No, you don't have to submit again. What if, most of you have already submitted, so you don't have to submit the exam. Yeah, Asok and I think Sukhvinder has already done. I've gone through Maimuna's assignment, so yeah. So yeah, those you have already submitted, they don't have to submit it again. Okay, now I would like to say goodbye, and although it doesn't make any sense to say goodbye because we'll be staying connected, and I would unmute you one at a time. If you have to say anything, you can say. Okay, so is it okay to unmute you, Rajiv? So yes, Sundar, you will get a certificate from us, which you can display on your LinkedIn as soon as you submit the project. Okay. So Rajiv, can I unmute you? Maimona, can I unmute you if you want to say anything? All right. Go ahead. Yeah.
Certificate, right? So we need to submit all the quiz and projects to get to the certificate, right?
Yeah, that's right. That's right, Rajiv.
Thank you.
All right. Uh, okay. So, all right, Rajiv, thank you for being part of this course and feel free and stay connected with us. Okay.
Sure, thank you so much.
All right. So, all right. Okay. All right. All right. So, yeah. So, Leela, Maimona, Asmeet, Mohsin, should I unmute you and you have to say anything? Okay. I'm unmuting you, Asmeet. Go ahead, please.
Have a nice meeting with all. Stay connected.
Okay.
Great course and great friends.
Okay. Great. Great. So be active on the Facebook community. We'll be adding other people as well. All right. Okay. All right. So, yes. Anybody else want to get unmuted and want to say anything? Okay. I'm unmuting you, Suraj. Go ahead.
Hello.
Yes.
Yeah. Sandeep, thanks a lot for the classes. It was far better than I ever imagined. And it was a lot of fun. And thank you for being so generous, extending the timelines and teaching us other things also, which we were not aware of, like Linux commands and stuff. And I had a really good experience with you, and I hope to be in contact with you in the long term also.
All right.
Thank you so much.
Thank you, Suraj. Thanks a lot. And I'm really happy that you like the sessions. Okay. Okay. All right. Okay. Prabhu, I would like to. Okay. Uh, yeah. Go ahead. Go ahead now. Yeah.
Hey, first of all, thanks, Sandeep. I really like the classes, and one thing I'd like to request you is if you can give us the opportunity to work on any real-time projects,
Okay.
that would be great. I think, to be very frank with you, if I get an opportunity to work on Hadoop, I may not be 100% confident
Hmm.
to right away jump in and do the things. But if you give us an opportunity to just get more familiar with real-time projects, I think that would help us more.
Okay.
And I'm happy to work on just as a voluntary thing to if you give me an opportunity, I'm ready to work on any projects or weekends or in the evenings
Okay.
to get more exposure to it. That's one thing I'd like to say. And for the rest of the class, I'm also interested if any of you are looking are working on some projects, and if you need any other hand to work on those, I'll be more than happy to work on those to get more exposure.
Great, great, great. So, Anjana would be sending you a form in which you can
Okay.
fill in the time slot which are comfortable with you, and then
Okay.
yeah, then we can. There are few projects which are coming up, so we are going
Okay.
to start working on. Basically, it's a IoT kind of a project whereby the data is going to be pushed to Hadoop, and from
Okay.
where we have to do the analytics. All right.
Got it. Sure.
Okay.
That would be great because I'm working in a company where they work on a lot of IoT data.
Okay.
So, and that would definitely be helpful. And I'm not working on any Hadoop role right now, but I'm looking forward to move into such roles.
Okay.
So that's the reason why I took this course.
Okay. Great. 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 All
Okay.
right. All right. Anybody else want to be unmuted? Yes. So, Mohammed and Maimuna's suggestion is that we create a LinkedIn community as well. So I'll do that, and I'll invite all of you, and then we'll stay connected that way as well. All right. So I'll unmute Sukhwinder. Actually, Sukhwinder can unmute himself. All right. Okay. Go ahead, Sukhwinder.
Yeah, uh, as Suresh said already, but I want to reiterate that I really want to thank you, Sandeep, for your time and patience with us on the questions we asked as a team. And honestly, I took a few courses in class, even in the class. I haven't seen the person so patient and interested to discuss things and explain the things the way you have done. I really appreciate and as other had said that I really look forward being a part of a team and a volunteer and take a more courses and suggest other peoples to take a courses on a no big data. Yeah, I really thank you for your time from bottom of my heart. Yeah, that's everything I wanted to say.
Okay. I'm really flattered. Thank you, Sukhwinder, and I'll try my best to keep. So generally what happens is my pre next batch is better than the previous one, as in, and that's why there is a delay. The planned one is actually 12 sessions, but because newer topics have come into play, say Spark streaming, and the other topics that have come into play, so we keep on extending a little bit. So that's why it has gone to that one. Okay, sure. Let me unmute Vivek. I think. Okay. Yes. Go ahead.
Hey Sandeep,
Hi.
thanks a lot for your efforts and for your patience. That was really great experience interacting with you. And I would like to mention one thing that it's not just the course that you are teaching us, but the other suggestions, like you told us to create a mark on the GitHub repository, and you suggested me to use a Eclipse plugin to commit those projects individually. So these are small things, but getting these things to know from you, it's really helping me a lot for a layman like me who doesn't have any experience in big data and analytics. Even the machine learning course suggested by you, it was wonderful. So I'm very happy to be a part of this big data community, and would really look forward to work along with you on any other projects that you have, and keep in touch with you all the time. Thanks a lot for your knowledge sharing.
Great. All right, great. I'm really happy, and yeah. I mean, I'll try my best to keep people happy in that way. All right. So, okay. So Mohammed is saying that what is the machine learning course? So I had suggested Coursera's machine learning course by Andrew Ng. You can go through that one. That's actually a good one. Actually, a good one. And all right. So, to all of you, basically, I'm working on this CloudX lab right now. So you must have seen my website. So we are basically, two of my students have joined me as well, and so this is essentially a CloudX lab, and this is where essentially we will be putting all kinds of tools. Okay. All right. So Leela's suggestion is that if I get, it'll be more beneficial to all of us. Sure. And one more thing, if you basically, if you uh, kind of share the, we will give you a kind of discount code for lab. If any of your friend is enrolling for the lab, you automatically get an extension of couple of months. Okay, so that we are trying to do right now. All right, I'll send you an email with the discount code which you can share with your friend. If somebody is taking up CloudX lab, uh, automatically it'll add to your I mean, we are keeping the pricing really, really low. As in, if you can see that the 2,500 for 3 months is something really low for if you think about all the cluster and all the resources. So, uh, so you can suggest to your friends and they can enroll for the course. All right. So yeah. So I'll recheck the date of your expiry of the CloudX lab, and we'll extend it from 2 weeks from today. Okay, we'll extend your lab from 2 weeks from today, and rest you can. Okay, and courses you can have access lifelong. These courses will be available for lifelong. The videos and the notes and these exercises will be available for you lifelong. All right. So thank you very much, and it was great to have all of you in the session. Great set of questions, and every session is a big learning for me. And we try to do as much as possible. But yeah, okay. Sure, Parvez. Let's have a talk tomorrow. Okay. And all right. I mean, I'm talking to Parvez. Parvez wants to talk because right now I have to rush. Okay. So great, great. Stay connected. Send me a request on LinkedIn and stay in touch. So, and you can always drop me an email. All right. Bye bye. Have a good day. All right.